Welcome. So, this particular set of modules that we are going to show it to you are regarding how to use your theoretical knowledge in practical applications. So, until unless whatever you learn in theory, in books, in lectures you do not apply, according to me it is useless. So, particularly when you are talking about linear integrated circuits or op amps or MOSFETs and their applications. So, what are the applications? So, what we will do today, we have divided this particular modules into several sections, so that the student can understand what are each equipment. Now, before we go to the equipment, like I said in my first lecture, I have shown you few integrated circuits, is not it, and I also shown you the passive and active components. So, let us see passive and active components. I will just bring it all the way here. So, if you can just little bit zoom in, yeah. So, we start with the capacitors. So, you see there are several kind of capacitors here. This 3 that I am keeping in front, let us not consider this 3, all these are capacitors, right. So, what are capacitors? Like we discussed last time, they are 2 parallel plates, conducting plates separated by a dielectric material or air. So, how we can measure this capacitor? What is the capacitance value? We can always see on the capacitor it is 63 volts, 10 microfarad, okay. But if I want to measure it, whether it is 63 volts or 10 microfarad or not, how would I know? So, we will also see what is the equipment used to measure this capacitor. There is the capacitance of this particular device. Now, capacitor, as we know, it is a passive component, right. Now, let us see the another one which is right in front of me. Again, if we can little bit focus on this component, yes. So, this is a PN junction diode. You can see there is a, this is a diode which I am holding in my hand, right, yes, and you will see a black, and if you focus right here where my nail is there, right here, there is a silver ring, there is a cathode. It is easy way of identifying diode, which is anode, which is cathode, which is P, which is N. So, when you say P and N, that means that you have 2 semiconductors, one is P, then one is N. That means we will see how we can measure the diode also. So, what is equipment to measure this particular diode, and we will also see several kind of diodes. If you really understand semiconductor devices, then there are several kind of diodes, tunnel diode, varactor diode, right, PN junction diode, Schottky diode. So, but this is a PN junction diode, it is simple, easy, but we have to also understand how we can measure, right, which is anode, which is cathode, not just by looking at it, but also by using the equipment. Now, let us see another one, and why I am kind of showing it to you, I am sure that you all know what are the components, what are the active components, what are the passive components, but it is always good to take all the students together. Unidirectional growth is not good, we should grow together, and that is why people who do not know how components looks like, right. Generally lot of universities they have the facility, however unfortunately few of the universities we do not have the experimental facility, and that is why the students may or may not know what are the active and passive components. So, for those students who do not know, this is what I am showing it to you. For those students who already know, it is kind of refresh. So, it is always good to refresh whatever we know, or brush up whatever we know, so that we do not forget, okay. So, now let us take the another one. This is beautiful, it is very easy to understand, and this looks extremely beautiful in terms of other components. What are these things? It's right, you have guessed, it is correct. What is this? Light emitting diode. One is yellow, right, one is green, we can have red, we can have bright field or bright, we can also have UV LEDs. However, we again do not worry about the functioning of this particular devices, because that is not scope of our particular series. The understanding about this particular series is what are the components and what are the equipment that we can use to understand how these components would be can be used right. So, this is light emitting diode, again it has a anode, it has a cathode. When you talk about diode, two ends, one is anode, one is cathode, alright, both has anode, both has cathode. Now, there is another way or easy way of identifying anode and cathode, but let us not go in that particular way of crude way of understanding which is anode, which is cathode. We will see in terms of how to understand which is anode, which is cathode in terms of a diode, whether it is PN junction diode or whether it is LED. We can always use a equipment called multimeter. So, we will see about multimeter in a while. Let us see another component or another device, which is this one. Now, let us keep this separate. What you see here? What you see here? These are resistors. These are resistors. Now, what is the value of this resistor, right? So, there is a chart to understand what is the value of this resistor, whether it is 100 ohm, 1 kilo ohm, 2 kilo ohm, 100 mega ohms, but there is another way of measuring the resistance, and that is using the multimeter. So, we will see how we can use the multimeter to understand what kind of what is a resistance value of this particular resistors, alright. So, resistors, another concept in DC is resistance, right, but if you understand AC, then the resistance is not any more valid and we have to understand the impedance. Again do not worry about impedance right now. The idea of this particular series is not to confuse you or not to make the life more complex. Life is very easy, same way any understanding of any devices, understanding of any subject can be make easier when we connect it to a real life problem, alright. So, resistors. So, now we will see what is the value of each resistor, okay. This is the idea that we see how we can measure the resistance or resistors and what is the value of each resistors. Now, let us go to the next one. I show you transistor. So, I will put it like this. So, you can see there are 3 leads, right. One transistor is NPN, another one is PNP, right. So, we will see which is NPN, which is PNP based on beta, which is current gain. Again we have to understand how we can measure the transistors, how we can understand whether this is PNP transistor, which is a NPN transistor. So, this is again a see metal can. So, it is a packaged, So, transistor is within this, alright, transistor is within this particular metal can, alright, within the metal can. So, you can all it's if you open this can, you will find a small chip which is your transistor. Let me again say that recently when we talk about integrated circuits, BJTs or bijunction transistors are not any more useful. We are not using it. What we are using it? We are using the MOSFETs. MOSFETs are metal oxide semiconductor field effect transistors. So, when we talk about BJTs, these are all discrete components. All the things that I have shown it to you until now are called discrete components, alright. So, let us see one more transistor, and this is the power transistor. So, let us start from the smaller one. This is a power transistor. Can you see a power transistor, right? Now, this power transistor, this black thing, what is this black thing? What is the use for this particular socket or black thing? The use of this particular thing is called heat sink, to sink the heat. What is sink? That will take away the heat or dissipate the heat. So, the heat generated by this power transistor is dissipated using this heat sink. This is for 2 watts. But if it is a higher wattage or it is a 5 watts, then we have a bigger heat sink. You can see again it is a heat sink, right. This black thing is heat sink, this is a power transistor, alright. So, this is also transistor, this is also transistor, this is also transistor, this is also transistor. So, do not get confused when somebody shows you okay this is a transistor or these transistors, both are transistors. The application is different, this cannot be used in power applications, this can be used in power applications. When there is a high power, there is a high energy, lot of heat, and heat we need to dissipate, otherwise it will cause difficulties in other electronic circuits. So, now I hope that we know most of the components or discrete components what we have seen. We will also see your favorite and part of this particular lecture and the part of this particular course is the MOSFET, right. So, you see this is the IC, this is the integrated circuit, right, and again there is a this for the heat sink. If you want to connect the heat sink, then you can connect it using this particular part. You see here this one, you can screw this and connect to a heat sink. There are 3 here, right, gate, source, drain, gate, source and drain. Source is internally connected to the substrate, so we do not have a separate connection for this substrate. Similarly, but if we want to use the MOSFET again, we can connect it to heat sink. Like I said, this particular thing we can connect to heat sink. You can see here it is connected through a screw, it is connected through a screw to a heat sink. Heat sink looks like this, right. We have seen heat sink looks like this thing, right. Heat sink looks like this, all right. This all black thing, they are all heat sinks, all right, got it. So, whenever we see anything we should be able to identify. Until we can not speak what is that, it is very difficult to ask a question. So, once you know that okay this is heat sink, what is the use of heat sink, right, but if you do not know what is this thing, then it is very difficult to ask. So, understand the terminologies, understand what are the components around in the circuit, and then you can have a lot of questions out of your curiosity, your interest, right. So, let us see the thing that we have already seen in the last class, and which is your integrated circuit, right. I have shown you this integrated circuit, is not it. So, this is integrated circuit. How about this? Is this integrated circuit? Yes, it is also integrated circuit, only difference is the number of pins. So, what is the difference between this and this particular IC here? This is op amp, which is single op amp, this is a quad op amp. Quad op amp is 4 op amps into one integrated circuit, quad op amp, right. So, instead of using 4 ICs which is single op amp, you can use one single IC which has all 4 op amps integrated into one single IC. So, the advantage of using this is it will require lesser space compared to single op amps, right. So, this is about the operation amplifier. We will see in detail what are the parameters of operation amplifier, and we will correlate with lot of experiments that what is the use, what is the application of this particular operation amplifier. So, for understanding the applications, for understanding the experiments, we should first know what are the integrated circuits, what are the resistors, what are capacitors, right, what are diodes, right, and then we should also know what are the DC power supply. How the power supply comes into picture, right, how you can give biasing to this op amp. We have not seen, we will see in the class number 2 or we have seen in the class number 2 or 3 if I correctly remember, that when we use an operational amplifier we have to give a bias voltage. This bias voltage is a DC voltage, this DC voltage is given using a power supply, it is a DC power supply. We will see in this set of experiments how the DC power supply looks like and how we can use a DC power supply, what are the newer version of DC power supply, what are the older version of DC power supply, that is variable, not variable, we will see this kind of things. Anyway, so how we will let us say we do not have this integrated circuits, we do not have integrated circuits, and what we have is we have all the discrete components. We have discrete components, that is your transistors, we have discrete components, that is your resistor, we have discrete component, that is your diode, we have discrete component, that is your capacitor, right. So, you have transistors, resistor, diode, capacitor, you have light emitting diode, is not it. Now, and you have a MOSFET. If I want to use these components, right, and I want to create a circuit to test the circuit. So, there are two ways. One is you make a PCB, printed circuit board, you can see here in this one, right, printed circuit board on which you have mounted several components including your integrated circuit. Where is it? Here, integrated circuit, right. You have capacitor. Where is capacitor? Now you guys should know this is capacitor, it looks like capacitor, right. What is matching to here? You see this one capacitor. Then there are two capacitors here, 4 actually, 1, 2, 3, 4. Can you identify? Yes, all right. Then you have capacitors here. Then you have ICs, right. You have integrated circuit. You have resistors. Can you see resistors? Then this is also capacitor. This one, this brown one, yes, this one. This is your paper capacitor. It's a paper capacitor. All right. Resistors, capacitors, and then your ICs, everything mounted on single printed circuit board. How it is connected? Is connected using a process called soldering. It is called soldering. You can see here it is all soldered, right, it is soldered. That means that once I have this PCB, I solder the components. If I test the component and the circuit may not work or is not working, then it is very difficult, because we have to de-solder it, we have to remove the solder, then only we can plug this out, that is plug the individual components out of the printed circuit board, out of this circuit, right. So, what is the alternative to this? Is there a way that we can test it and then we make this PCB? So, we do not have to alter these things again and again, right. So, for this particular same way, if you see this one, right, it goes to many more complex layers, but you see this one, right, is even more complex, right. See, so many components soldered together, see, soldered together. Now if something happens and then there is a fault, it is, we have to first understand where is the fault. If we find out the fault, let us say capacitor is faulty or IC is faulty, you have to de-solder it and you have to take it out. Now doing this thing is a big pain, and which is not okay. That is why what we can do, we can test this component, test this circuit before we do the soldering. So where we can test this circuit, right, there is the next question, how we can test this circuit. If I cannot solder it, is there an alternative arrangement to test the circuit? So the answer is yes. Answer is yes. Answer is this beautiful thing in my hand here, right. Maybe you cannot see because of my pink shirt. Now you can see, this is zoom in. This is called breadboard. Name is very interesting, right. So it was earlier used to actually cut the bread. It was a polished wood used to cut the bread, right, and later in 1970s people have invented this particular board, and we call this a breadboard. It is also called as with a different name. For us recently, or in most of the universities or most of the instructors, they will tell you use breadboard. This is breadboard, this is also breadboard, right, easy. Advantage here, you do not have to do any soldering, the breadboard is integrated or internally it is connected, Now here you see this line and this line, right, there is rows and there is columns. So you can use either positive, see newer breadboard comes with this sign, so it is easier. You have this in positive, plus, you see minus, right, plus minus, or here plus minus. So you can connect the positive terminal to plus, ground to minus, right, and then you have rows and columns. So I can connect a resistor, I will just show it to you. This way, you see, easy to connect, right. So if I make the entire circuit on the breadboard, entire circuit. So now again understand this line, that is, let me show it to you with another resistor. This particular line, this one straight, this is connected, the next one is not connected to second one. So, let us focus here, let us focus here, alright. Yeah, this one is not connected with the next one, but this one is connected to here. This whole column, if you consider this as a column, my line as a column, whole column is connected, but the next one is not connected with the first one, alright. That is why I connected resistors like this, not resistor like this. You see, I have not connected resistor like this. Is it correct? Right. So, anyway, you will know, and I am sure that you have used this breadboard. The point that I am making is that you can use this breadboard to create entire circuit which you are looking at here. So, instead of this PCB, create the circuit on the breadboard and then test the circuit. Once your circuit is okay, then you use this particular printed circuit board and solder your components, right. So, breadboard is an alternative approach, is a better approach to make the circuit and test it, and then we move on to the printed circuit board, alright. Now, because there is a lot of time, you know, this positive negative is here, but what about this particular breadboard? Can you see this particular breadboard? It does not have any sign positive negative. Can you see any positive negative sign? There is no sign, right. So, alternatively we can, there is a connection given to this breadboard such that this red one is not actually connection. You can use any line as positive, any line as negative by connecting this terminal. So, you do not have to use the pins, you do not have to use the wires to connect it here. You can use directly DC power supply, you can give the ground to here, positive to here, and so on and so forth. So, this is a easier way of using a breadboard. This is a bigger size of the breadboard compared to this breadboard. That means that you can have a bigger circuit here, or you can test multiple circuits on the single breadboard, right. That is the advantage of using a breadboard compared to the smaller breadboard. Now, when we say that we are using the breadboard, we are mounting the resistors, we are mounting the capacitors, we are mounting transistors. First thing is that whether the resistor we are using is of the value that we want. For example, if I say that we want to use a resistor of 100 ohm, how you make sure that the value is 100 ohm, right. So, to understand this thing, we have something called multimeter. You see, this is how it looks. I am sure, again, like I said earlier, that lot of people, a lot of you guys have already seen how a multimeter looks like. For those who do not know how multimeter looks like, for them this is the multimeter, and I will show it to you the functions of the multimeter in actually okay. Just now I am just showing it to you. This is how a multimeter looks like, alright. This is a multimeter. You can just focus it if you can. Same way, this is also a multimeter, alright. Both are multimeters. You can see digit, if I turn it on, you will see some digit, right. If I turn it on, we see some kind of digits, right. Actually this is not connected, so it is showing 0, right. So, this digits, that is why it is a digital multimeter, digital, right. When you can see display, you can see the readings, right, in terms of digits, digital multimeter. Now, we will see what are the functions, or what are the things that we can do with a multimeter, alright. So, one is on my hand, and it is easy to identify. I can identify like it is yellow, right. This is orange and grey, right. Now, let us see the role of each digital multimeter and how we can measure the components, alright. So, for now let us quickly understand that we have components, we have resistors like components like active devices, passive devices, and then we have a breadboard, and before we implement a circuit on the breadboard, right, before the final implementation of the circuit on the PCB, we have to use a breadboard, and before implementing on the breadboard, we should know what is the value of each component. To measure this value, we can use this particular equipment called a digital multimeter. Now, there are probes. These are called probes, alright, which is in my hand. Probes, you see, one is red, one is black, easy. One is black, one is red, right. So, black is ground or common, right, and you will see here, if I just take out this probes, you see here what is written, volt ohms, right. See volt voltage and ohms resistance, right. Then this is common, that is written here, warning is a warning, 1000 volts DC, 750 volts AC, 1000 volt DC, 750 volts AC, means that you cannot operate this equipment at that particular voltages, this is too high, it will cause damage, or it will damage the multimeter, you cannot go to that level. Now, if you want to measure current, right, this is voltage and resistance, if you want to measure the current, then we have this milliamperes and amperes, you can see milliamperes MA, amperes A, capital A here, right. Now, there are several functions on this multimeter, several functions, all right. We go from here and then we actually measure the value of the components, all right. The first thing, let us see, this is off. So, can you go to the display, see display is off, all right, this is off, easy. Now, we go towards this side, this is AC voltage, AC voltage, can you little bit focus, yes, very good, 750 volts AC. Now, we go further, 200 volts AC, maximum we can measure 200, if you give 350 volts you cannot see anything, if you want to measure 350 volts you have to convert back to 750, all right, these are knobs, 200, 20, 2, right, 200 millivolts. Same way DC ampere, right, 200 microampere, to that range 2 milliampere, then you can go down, right, 200 milliampere, 20 ampere. Similarly, AC voltage here, you see 20 ampere to 200 microampere. Then we go to this particular section which is called HFE. This is used for measuring the transistor. You can see here it is very easy, right, NPN transistor or PNP transistor, right, NPN, PNP transistor. So, we will see how we can attach the transistor and what kind of display we will see on the multimeter when we do the actual experiment. Now, let us go to the next section which is your, what is this, off, again it is off here, one off is in the, is 180 degree, right, if you consider 0 is 180, all right. Then next one is diode, next one is for understanding the short circuit, it is easy to understand if there is a continuous connection, that also we will see. Then we have this resistance, you see there is a ohms, right, here we can see there is a symbol ohm, ohm is for resistor. We start from 200, we go to 2 kilo ohm, 20 kilo ohm, 200 kilo ohm, 2000 kilo ohm, or you can say 20 mega ohm and 200 mega ohm, until 200 mega ohm it can measure, right. Then we go to DC voltages, DC voltage starts from 200 millivolts, 2 volts, 20 volts, 200 volts, 1000 volts, right, and we come back to our original point which is your off. This is the function of this particular multimeter. Now, can this multimeter measure frequency? No, there is no option of measuring the frequency. So, how about we see the another multimeter, right, which is the orange one. Let me switch it off. Always remember, if you do not switch off the multimeter it will consume the battery, it will consume the power. There is a battery here, you can connect, you can open it and you can insert the battery on the back side of the multimeter. This operates on the generally 9 volt battery. Okay. We see another multimeter, again in multimeter there are probes, these are called probes, right, PROBES, probes, all right. I will remove this one, remove this, okay. Now, off, you cannot see anything, correct. Now, what are the different things here? One is towards here, if I go towards this side, right, that is towards the in the anti-clock direction, if I go anti-clock then I can see voltage, right, this is correct, and if I go in a clockwise direction, clockwise, then I can see current, you see 10 amperes, AC and DC, it can measure both AC and DC, go to milliampere, go to microampere, right. If I go to anti-clockwise I see voltage AC and DC, you see if you still focus further, if you can, the single line, straight line is DC, right, a sine wave kind of thing. You see here sine wave kind of thing. This is your symbol for AC, alternative voltage, DC direct current or direct voltage. Okay. So, next one here, what is that? You can measure capacitor, you can measure diode, you can measure resistors, all three things you can measure, right. You can change the mode here. You see there is a auto power off, is a auto mode, you can see here auto mode is there, right. You can change the mode from auto to capacitance mode or resistance mode, or you can change the value. Suppose it's a higher value of resistor, you can again change the mode. Now, next one would be your hertz. See this function was not there in the earlier multimeter. Hertz is nothing but frequency, right. So, we can measure the frequency using this multimeter, we cannot measure the frequency using this particular multimeter. I am not telling that this multimeter is better than this multimeter, that is not the goal of this lecture series. So, don't worry about who manufactures it, that is not our idea of telling you buy this multimeter or buy that multimeter. Our idea is to understand, if you get a multimeter or if you have the multimeter, what are the parameters within the multimeter that you can use it and you can operate it for measuring different components or other parameters like DC voltage, AC voltage, DC current, AC current, resistance, capacitance, frequency, right. You can also measure temperature, and with the advancement of electronics, like I said that there is more analog electronics in a digital multimeter. If you see this digital multimeter, if you really open it, there is a lot of analog components. But anyway, the point that I am making here is, now we have one more thing, which is the temperature. So, if you see here, this is on the temperature, that means we can also measure temperature. So, what we can measure? We can not only measure the resistance, we cannot only measure the capacitance, we cannot only measure the frequency, we can also measure the temperature. That means, what is the room temperature right now, or what is the temperature of particular surface, that we can measure. For that we need a separate probe, alright, and this probe is here. So, I will put this multimeter down, because right now our function or our application is to measure the temperature. Again, do not worry about the company, like I said, you select a best thing. For example, if somebody wants to buy a multimeter, they will go for Fluke. It is even more precise, more costly, right. But we right now the goal is not to understand which is costly, which is precise. Goal is to understand, if you have a multimeter, can you measure the resistors, can you measure the capacitor, can you measure the devices, can you measure the components, that is the only goal, alright. So, now we have this particular sensor, we have nothing but, if you see the tip, the tip is, so let me show it to you so that you can see the tip. Yes, you can see the dot here, right, and that tip is nothing but your thermocouple. You can see here, right, this tip, this one is your thermocouple, alright. So, we will see the function of thermocouple sometime else, but understand that this is also kind of temperature sensor, it can measure the temperature. Now, whatever temperature it measures, it gives the output in terms of millivolts. So, if your electronic circuits already know that the millivolt obtained as the output of this particular sensor, and you have the values, you can correlate it with respect to temperature. So, here you will not be able to see millivolts, here you will be able to see degree centigrade, you see here degree centigrade. So, how to connect this probe to this particular multimeter, alright. So, here again you see here, what is it done, 10 ampere current, next common ground, right. Here see volt, resistance, temperature, hertz, milliampere, microampere, means you can, if you measure voltage, you can connect to this particular terminal, you have to connect temperature, you have to connect between this and common, if you want to measure frequency, you have to connect this and this, if you want to measure milliampere, microampere current, you have to measure this and this. Only when it goes to higher current is 10 amperes in amperes, then you have to connect this particular terminals, alright. So, what I will do is I will open this, right, there is a this thing. So, we open it, you see here, and then we open the another one. Now, we will insert it. Now, it is very easy, right, black and red, I said black and red. So, I will keep it like this. What I have done, I will open it again to show it to you what I have done. You see red goes here, black is common, right, and we insert it, right. Now, if I keep it here, it is in temperature, this is a thermocouple, right. So, it will try to measure what is the temperature of the this particular room, and what you can see is it is around 22 degree centigrade. Why 22 degree centigrade? Because air condition is on, so is around 22 degree centigrade, all right. So, it is kind of easy way of utilizing multiple things within the same device, right. So many things you can do by having just a single device. But if I touch this thermocouple, you will see the change in temperature. If I touch the thermocouple, you will see the change, because the heat here in my hand within two fingers is more than the room temperature. You can immediately see the change in the temperature, that is degree centigrade, right. From 22 it came to 29.5. If I generate more heat by rubbing the hand, it will even show more, but again the point that I am making is there is a provision of measuring a temperature, there is a provision of measuring frequency. So, do not come under the impression that the multimeter cannot be used to measure frequency, the multimeter cannot be used to measure temperature, right. There are devices that we even do not know, right, and there are equipment that we are not able to understand, we are not able to utilize it, we are not able to look at it in our undergrads, right, because we all come from universities where they focus on theory and they focused on a certain set of experiments, but they may not have enough facility to give you all the components which are high end technology. That is absolutely correct, that is absolutely fine, no worries about that. What you should understand is that given a set of equipment, what is the use of those equipment and can you use it for particular experiments, right. So, the final goal is not to understand just the equipment or just the devices or just the integrated circuits, final goal is to apply it. Until you apply it, again I am saying this again and again, theory is very important, theory is extremely important, but if you do not apply into practical, it is not useful. So, use theory, understand theory. I am talking about this particular lecture again, right. It depends on if you take up mathematics, right. Again if you see mathematics also, there is lot of application of mathematics, lot of application of physics, lot of application of chemistry, right. So, actually until unless you translate it to experimental, your theoretical knowledge, you are not doing justice to your theoretical knowledge, that is what I can say. So, let us see now what are the experiments that we will be performing in a course of time. Actually, before we move to the list of experiments that we will be performing in the course of time, first my idea is that you should know that what are the equipment. So, we have now seen, if I quickly repeat, we have seen discrete components, we have seen PCB, which is this one, right, this one. Then we have seen the soldering, we have seen what is the alternative to that, which is your breadboard, we have seen this breadboard, right. Then we have seen a multimeter. Multimeter is a device that can be used to measure resistance, capacitance, right. It can be used to measure temperature, it can be used to measure frequency, it can be used to measure the diode, it can be used to measure NP and PNP transistors, whether transistor is NPN, whether transistor is PNP, right, and so on and so forth. So, very important device, very important device. Now, let us move to the next set of device one by one, and before we move to the next set of device, first let us see how multimeter is used for measuring the different components, alright. So, for this particular module, this is the end of this module, and the next module we will look at the different values of the discrete components, alright. Thank you, and I will see you in next module.